Chapter 1: Overview of Microsoft Fabric and its core components. Introduction. As data volumes continue to grow and analytics use cases become more complex, organizations across every industry are turning to data as a key driver of digital transformation and competitive advantage. The real challenge, though, isn't a lack of tools, it's fragmentation. Most organizations rely on multiple specialized products to build an end-to-end analytics system. One tool handles ingestion, another handles storage, another handles transformation, another analytics, another reporting. Stitching these systems together introduces high integration costs, operational complexity, and ongoing maintenance overhead. As a result, teams often spend more time keeping systems connected and data in sync than actually delivering insights. And in many cases, by the time insights are produced, the information is already outdated and no longer actionable. This is the exact gap Microsoft Fabric is designed to close. Fabric takes a more unified approach to analytics by bringing core capabilities together in a single integrated platform. Instead of managing disconnected tools, it focuses on simplifying the analytics lifecycle and reducing the friction between data, analytics, and insight. In the next part, we will start breaking down what Microsoft Fabric is, the core capabilities it offers, and how it addresses these long-standing challenges in modern data analytics. What this chapter covers. In this chapter, we will focus on building a strong conceptual foundation for Microsoft Fabric. We'll begin with an introduction to Microsoft Fabric and the problems it was created to solve. From there, we explore its core capabilities and how those capabilities come together to form a complete analytics platform. We'll also look at how Fabric supports multiple types of analytics workloads through native integration, allowing real-world use cases to be implemented without stitching together disconnected tools. In addition, this chapter discusses how Microsoft Fabric enables broader participation in a data-driven culture across an organization, and how built-in AI assistance, including Copilot, helps increase productivity. Finally, we introduce the idea of Microsoft Fabric as a unified business model with shared universal compute capacity across workloads. By the end of this chapter, you will have a clear, high-level understanding of Microsoft Fabric, what makes it different, and how it addresses the core challenges faced by data analytics teams today. Introduction to Microsoft Fabric. Microsoft Fabric is an end-to-end, all-in-one analytics platform designed to bring everything an organization needs for analytics into a single, unified experience. Instead of working with separate tools for data management, data lakes, ingestion, engineering, warehousing, data science, real-time analytics, and business intelligence, Microsoft Fabric brings all of these capabilities together on one platform. The goal is simple: reduce complexity, lower operational costs, and shorten the time it takes to move from raw data to meaningful insights, especially in the era of AI. Fabric is built on top of Azure and takes advantage of Azure's underlying strengths, including scalable compute, reliable storage, built-in security and governance, high performance, and global networking. All of this infrastructure is handled for you, allowing teams to focus less on managing systems and more on working with data. At its core, Microsoft Fabric is about simplifying analytics by design, bringing data, analytics, and insight together in a way that feels cohesive, consistent, and integrated from the very beginning. Reviewing the core capabilities of Microsoft Fabric. Microsoft Fabric is built for the age of AI, and it is delivered as a single software as a service platform. Instead of being a collection of loosely connected tools, Fabric is designed to work as one integrated system. It provides built-in integration across workloads, automatic optimization behind the scenes, a shared architecture, centralized security and governance, and a unified business model, all wrapped in a consistent Office-like user experience. The idea is that no matter which type of work you're doing inside Fabric, the experience feels familiar, connected, and cohesive. At the core of Microsoft Fabric are 4 key capability pillars. These pillars explain how Fabric is structured and why it works the way it does. Those pillars are a complete analytics platform, a lake-centric and open architecture, empowering every business user, AI-powered experiences. We'll walk through each of these pillars in detail, focusing on what they mean in practice and how they show up when you're actually using Fabric. Core capability number 1, complete analytics platform. When people talk about analytics systems, whether it's a data warehouse or a data lakehouse, the overall pattern is usually the same. You ingest data, you process it, and then you serve it to the users. The problem is that each of those steps often require very different capabilities, and historically, they've been handled by completely different tools. One product for ingestion, another for processing, another for analytics, another for reporting. Sometimes those tools come from different vendors. Sometimes they come from the same vendor, but they don't integrate cleanly. Either way, the result is usually the same. Complex architectures that are expensive to build, fragile to maintain, and time-consuming to operate. This is where Microsoft Fabric takes a different approach. Fabric is a single, unified platform that covers everything an organization needs to build an analytics system, from small departmental solution all the way to large enterprise environments. It supports the entire lifecycle, ingesting data from many different sources, transforming it at the right scale using familiar tools such as SQL and Apache Spark, and serving insights to business users through Power BI, all with shared security and governance across the platform. Instead of stitching systems together, everything works cohesively by design. Best of breed engines, one platform. With Fabric, you're not giving up flexibility or power in exchange for simplicity. Under the hood, Fabric brings together best-of-breed engines and capabilities, but exposes them through a single unified experience and architecture. This means you can integrate data from on-premises systems or the cloud, apply transformations using the languages and tools that you're already comfortable with, derive insights, and present those insights to business users, all without jumping between disconnected platforms. Because Fabric is delivered as a software as a service platform, integration and optimization happen automatically. You don't need to provision infrastructure, wire services together, or manage scaling manually. You can sign in, start working within minutes, and focus immediately on creating business value. Just as importantly, Fabric is designed so that different teams can work together on the same copy of the data. Data engineers, data warehouse developers, data scientists, data analysts, and business users all work within role-specific experiences, but they're building on top of each other instead of operating in silos. Workloads that cover the entire analytics lifecycle. As a complete analytics platform, Fabric provides a set of core workloads that are natively integrated with one another. The idea is simple. You should spend time generating insights, not integrating tools. Fabric includes workloads for data integration, data engineering, data science, data warehousing, real-time analytics, business intelligence, and automated data-driven actions. For data integration, Fabric includes Data Factory, which combines the scale and power of Azure Data Factory with an intuitive UI-driven experience. It supports a large number of built-in connectors for both on-premises and cloud data sources, along with drag-and-drop transformations and pipeline orchestration. For data engineering, Fabric provides a Spark-based experience designed for large-scale data transformation and collaboration. Spark environments are available almost instantly, making it easier to work with data and iterate faster. These Spark jobs can also be orchestrated as part of broader data pipelines. For data science, Fabric enables teams to build, train, deploy, and operationalize machine learning and AI models directly within the platform. Experiment tracking, execution tracking, and model management are all built in, allowing data scientists to collaborate and integrate predictive insights into analytics workflows. For data warehousing, Fabric provides a modern SQL-based experience that combines traditional data warehousing concepts with lakehouse flexibility. Compute and storage are separated and can be scaled independently, and data is stored in open formats to support interoperability. For real-time analytics, Fabric supports streaming and event-based scenarios, allowing teams to ingest and analyze high-volume, low-latency data such as telemetry, logs, and IoT signals. These workloads are designed to handle changing schemas and large data volumes efficiently. Power BI is fully integrated as the reporting and visualization layer, allowing business users to explore data, build reports, and make decisions using familiar tools. Because Power BI is part of the same platform, it works directly on shared data without unnecessary duplication. Fabric also includes Data Activator, which enables automated monitoring of data patterns and can trigger alerts or actions when specific conditions are met, all without writing code. Built on a SaaS foundation, a key design choice in Fabric is that everything is built on a shared software as a service foundation rather than a traditional platform as a service model. This doesn't reduce control or capability. Instead, it removes friction. Onboarding is simpler, provisioning is faster, scaling happens automatically, best practices are applied by default. For example, workloads start up in seconds instead of minutes, and many performance optimizations are handled automatically so that you don't have to spend time tuning low-level settings. Because all workloads share the same foundation, switching between experiences feels seamless. A table created using Spark can be queried using SQL or used directly in Power BI without moving or copying data. assets are easy to discover, reuse, and collaborate on across teams, and different users can work in the tools they prefer while still sharing the same underlying data. Centralized administration and governance. Fabric also simplifies administration. Security, governance, monitoring, and capacity management are handled centrally across all workloads. Policies are defined once and enforced consistently, and usage can be monitored at both the workload and job level. This makes it easier to understand resource consumption, manage costs, and support enterprise governance requirements without adding operational overhead. Persona-based experiences. Finally, Fabric is designed around persona-based experiences. Each workload is optimized for a specific type of user, such as data engineers, data scientists, data warehouse developers, real-time analytics developers, Power BI developers, and data integration specialists. Instead of overwhelming users with every possible option, each experience surfaces the tools, tasks, and resources that are most relevant to what that particular role needs to get done. This reduces noise, shortens the learning curve, and helps teams move faster while still working together on a shared platform. Core capability number 2, lake-centric and open. In most analytics environments today, data doesn't live in one place. It's spread across different systems and different storage layers. Some data sits in a lakehouse, other data lives in a warehouse, some of it exists in proprietary formats. And very often, the same data is copied multiple times just to make it usable by different teams and tools. This creates duplication, complexity, and a lot of ongoing maintenance. Keeping everything in sync takes time, costs money, and slows teams down. This is the problem Microsoft Fabric addresses with One Lake. When a Fabric tenant is created, One Lake is automatically provisioned and configured. You don't need to set it up manually. It's just there by default. One Lake acts as a single, unified data lake for the entire organization. A simple way to think about it is this. One Lake is like OneDrive, but for your data. All Fabric workloads share the same One Lake, which means data is no longer fragmented across isolated storage accounts. Instead, everything lives in one logical lake that's accessible across the entire platform. One lake and one copy of the data. Under the hood, One Lake is built on Azure Data Lake Storage Gen 2. It supports structured, semi-structured, and unstructured data, and it works with the same APIs and SDKs that the existing ADLS Gen 2 applications already use. That means existing tools and integrations, including platforms like Databricks, can continue to work without being rewritten. For each workspace in Fabric, a container is created automatically, and data is stored in a familiar folder hierarchy within that container. The idea here is one copy of the data. With One Lake, all analytics engines in Fabric can access the same lake directly. There's no need to copy data from a lake to a warehouse just so that SQL users can query it. There's no need to duplicate data again to build reports in Power BI. Instead, every engine sees the same data and just works on top of it. This removes the chaos of siloed storage accounts and makes discovery, sharing, and collaboration much simpler, while still enforcing security and governance centrally across the platform. Open formats by design. Another important part of this approach is openness. Fabric standardizes on the open source Delta Lake format for tabular data. By default, all computing engines in Fabric read from and write to Delta Lake. This means data doesn't need to be converted or copied just to move between engines. A table created in a lakehouse can be queried using SQL, used by Spark, or consumed by Power BI, all without moving the data. Using an open format also avoids vendor lock-in and ensures compatibility with a wide ecosystem of tools and technologies. Shortcuts. Access data without copying it. OneLake also introduces the concept of shortcuts. A shortcut is simply a reference to data that already exists somewhere else. Instead of copying data into OneLake, you link to it. These shortcuts can point to data in other Fabric lakehouses, external Azure Data Lake storage accounts, or even storage in other clouds such as Amazon S3. Once linked, the data appears as if it lives locally in OneLake. From a user's perspective, it just works. This creates a powerful data abstraction layer across the organization, making data sharing as easy as sharing files, without duplication or movement. Domains and data mesh patterns. Shortcuts also enable more advanced architectural patterns. Teams working in different workspaces can combine data across business areas into virtual data products without physically moving the data. This makes it much easier to implement data mesh-style architectures. Fabric supports this through the concept of domains. A domain is a logical way to group data and related code artifacts around a specific business area. For example, finance, operations, or marketing. Each domain can manage its own data according to its own rules and requirements while still contributing to the same underlying data lake. Data from different domains can be analyzed together, secured centrally, and certified by domain experts, helping build trust and discoverability across the organization. One security model across everything. All of this is tied together with a shared security model. Fabric uses a single security definition that's enforced across all engines. Permissions defined once, at the lakehouse level, are automatically honored by Spark, SQL, and Power BI. Access can be controlled at the level of tables, files, or folders and assigned to individual users or identity groups. This keeps security consistent and predictable without having to redefine it for every tool. At a high level, the lake-centric and open approach in Fabric is about removing duplication, reducing friction, and letting every workload work against the same data, securely, efficiently, and without unnecessary complexity. Core capability number 3, empowering every business user. One of the biggest advantages of Microsoft Fabric is how it brings everyday business users into the data-driven process. Microsoft 365 applications are already some of the most widely used tools in the world. People live in them every day, checking emails, working in spreadsheets, collaborating in meetings, and building presentations. Fabric is designed to meet users where they already work. Microsoft Fabric integrates deeply with Microsoft 365, turning familiar applications into entry points for discovering and using organizational data. Power BI plays a central role here. It's a core part of Fabric and is already woven throughout Microsoft 365 applications. Because of this integration, business users can discover and access data stored in OneLake directly from tools they already know, like Excel, Teams, PowerPoint, and SharePoint, without needing to learn entirely new systems. In Excel, users can explore and analyze data from OneLake and generate Power BI reports with just a few clicks. In Teams, data and insight can be embedded directly into chats, channels, and meetings, making analytics part of everyday collaboration. In PowerPoint, users can embed live Power BI reports into presentations, keeping insights up to date instead of relying on static screenshots. And through SharePoint, insights can be easily shared and distributed across the organization. This approach turns Microsoft 365 applications into hubs for applying insights rather than just places where work happens separately from data. Core capability number 4. AI-powered experiences. A big part of what makes Microsoft Fabric different is how deeply AI is built into the platform. Fabric integrates natively with Azure OpenAI service with the goal of making AI accessible to everyone, not just data scientist or data engineer. The idea is to help users unlock more value from their data and find insights faster by working in a more natural, conversational way. With Copilot available across Fabric workloads, users can interact with the platform using plain language. That includes creating data pipelines and data flows, generating code in SQL or Spark, building machine learning models, documenting logic, and even creating reports automatically. Instead of starting from a blank screen, Copilot helps reduce friction by assisting at every stage of the analytics process, from data preparation to modeling to visualization. Fabric also allows teams to go on a step further by building their own conversational experiences. These can combine Azure OpenAI models with organizational data and be published as internal contextual AI experiences. This makes it possible for users to ask questions and get answers directly from their own data in a way that's tailored to their organization. Just as important is how security is handled. Copilot in Fabric follows Microsoft's enterprise-grade security and privacy commitments. It respects existing organizational policies around security, compliance, and data access. Organizational data is not used to train the underlying foundational models, and access to data is always governed by the same permissions that are already in place. The result is AI assistance that's powerful, practical, and safe to use in enterprise environments. Unified business model with universal compute capacity. Another core idea behind Microsoft Fabric is simplifying how compute is purchased, managed, and shared. Traditionally, analytics systems are built using multiple products, often from different vendors, and each of those products requires its own compute capacity. Data integration has its own capacity, data engineering has its own capacity, warehousing, real-time analytics, and reporting all have their own capacity allocations. This creates two problems. First, cost management becomes very complex. Second, when one component is idle, its compute capacity can't be used by anything else, leading to waste and a higher total cost of ownership. Fabric takes a different approach. Instead of provisioning compute separately for each engine, Fabric uses a single universal compute capacity measured in capacity units. This single pool of compute resources is shared across all Fabric workloads, from ingestion and transformation to data engineering, data science, warehousing, real-time analytics, and Power BI. This means you don't have to pre-allocate or size capacity for individual engines in advance. Any workload can use available compute as needed, and unused capacity in one area can be consumed by another. From a cost perspective, this model is simpler and more efficient. You pay for two things: the compute capacity you provision, which is shared across all workloads, and the storage you consume for your data. Capacity can be shared across multiple users, projects, and workspaces, and it can scale as demand grows, either by upgrading the capacity tier or using auto-scale features when needed. The end result is a more flexible, transparent, and cost-effective way to run analytics at scale, without constantly juggling capacity across disconnected tools. Wrap up. At this point, you should have a clear picture of what Microsoft Fabric is and why it exists. Fabric is designed as a single, unified platform that brings together everything needed to build end-to-end analytics systems, from data ingestion and transformation through data science, data warehousing, real-time analytics, and all the way to reporting and visualization with Power BI. We've looked at how Fabric's core capabilities work together, especially concepts like one lake and the idea of working with one single copy of data. By standardizing on open formats like Delta Lake, Fabric breaks down data silos, removes unnecessary duplication, and keeps the platform open rather than locking data into proprietary systems. We've also covered how shortcuts make it possible to access and work with data across environments, even across clouds, without physically moving or copying that data. This creates powerful data visualization patterns and opens the doors to more modern architectures like data mesh without adding more complexity. On top of that, we explored how Fabric simplifies operations through a unified business model. Instead of managing separate compute capacity for every tool, Fabric uses a shared pool of resources and compute that all workloads can draw from. This makes cost management simpler, improves resource utilization, and helps reduce overall total cost of ownership. With these fundamentals in place, you now have a solid understanding of how Fabric is structured and how its pieces fit together. Next, we will start going deeper into the individual workloads, what each one is designed for, when to use it, and how different use cases map onto the platform in practice.